You're on.
Here we go. We're on problem number. Shoot, I didn't put a problem. What problem number is this?
This is problem number 4.
Problem 4?
Yeah.
No, problem number 5.
Problem number 5.
Number 5, okay.
Sorry.
So problem number 5, and we're solving for x here. Now we get to the meat of this, the crunchiness, the crustiness, crusty, crunchy, hairy. It's all now packed in these guys, so we want to pay careful attention here. Our goal is to solve for x, and I also wrote in the directions up there, you don't need to put it in decimal form, so I'm just going to leave it. I'm not even going to use my calculator here. I'm just going to leave them in decimal form though. Except that I think I may need to use my calculator to do maybe like these divisions over here, so we'll see here. Alright, so basically right now if we want to solve for x, we have 160 times e. So if I want to get rid of my 160, I want to get rid of my coefficient, right? So I'm going to divide both sides by 160, okay? And I have no idea what that is, but my calculator does. Alright, so 130,000 divided by 160. Cool, so we get 81.5. So I bring down my e to the power 0.02x equals 812.5. Alright, so now this is now going to test your ability to get rid of our e by using our inverse property now. And basically what's going to happen here is that what can we do to both sides of our equation, right? Because it's an equation, so we have to do the same operation to both sides. What can I do to both sides of my equation that would eliminate this e, right? Or so that we can bring this down? Well, we know that our natural log has a base e. And from the examples that we saw from the previous problems, that happens quite nicely when our base, which here is e, and what we're taking the log of, if it's the same thing, then that means that they can cancel out. So notice what I just did. I took my exact same thing on both sides, and I took the natural log of both sides. We want to do that because since this has a base e, that's what you're going to do right there, right? And now that's why we can just bring down 0.02x equals the natural log of 812.5. And lastly, if you just divide it by 0.02, okay, you're going to get full credit right there. You didn't have to turn this into a fraction. Okay, so if you left it like this, okay, there's nothing wrong with that. That's a precise answer. Okay, or you could have turned 0.02 into let's see, if you did 0.02 into a fraction, you could have done 1 over 50. So you could have said. Another way of doing this is you could have done 1 over 50 times the natural log of 812.5. You could have done that as well. 0.02 is 1/50th. So these two are equivalent. Both answers are precise answers. You didn't have to put it in decimal form. So either one would have given you the full thumbs up there. Okay. The second problem now. Let's go ahead and get rid of a few things here, such as this negative 28, okay? I don't want to divide by 3 yet, because if I divide by 3, I have to divide 3 into 28, which is going to give us a fraction. So let's first deal with adding 28 first to both sides. Okay, so we get rid of that. We can drop this down right here. So 2 to the negative 5 minus x. So what's that going to give us right there? 8, 9, 10, 6, 7, 8, 9, 6, 2 right there. Okay, and then let's go ahead and get rid of this coefficient, 3. So we're going to divide both sides by 3. So we get 2 to the power of negative 5 minus x equals this nice little calculation. 2690 divided by 3 gives us a fraction which is actually the same one. So I'm actually not going to put it in a decimal form because it's a repeating decimal. So I'm just going to leave it like that. Let me explain that again. The reason why I'm going to leave it like this is because when you put it in your calculator, it's the 0.666667, so I'm just going to leave it in this precise fraction right there. So this problem now becomes very similar to what we did over here, where I said, okay, what can I do to both sides to get rid of e? I said, oh, let's take the natural log because it has a base e. So right here, how can I get rid of my 2? Well, I can take the log with a base 2 now, right? So I'm going to take the log of both sides with the base 2, and I'm doing that because those are going to be eliminated. That's the reason for that. And then we have this whole thing right here. Okay, so I just took this whole thing, it's on both sides, and I put the log right there. Oh, base 2. Very nice, watch this. And so that's gone there. So we just bring down negative 5 minus x equals log base 2 of 2690 divided by 3. I'm going to, that's fine, I guess it's kind of low here. We'll deal with it. Let's go ahead and add 5 to both sides. I'm going to add 5, I'm going to add 5. So now I'm going to come up here though now, okay? So I'm going to write negative x equals, right? So that's gone, so I have negative x equals, I'm going to put my 5 in the front though. And so that it's not confusing that I'm not adding 5 to this. I'm really going to say 5 plus this whole thing, log base 2 of 2690 over 3. And last but not least, let's go ahead and get rid of our negative x by dividing both sides by negative 1, or multiplying both sides by negative 1. So I'm going to multiply both sides by negative 1. So finally, x equals, it goes from a positive to a negative now when you multiply by negative 1, so negative 5. And it goes from a positive log to a negative log right there, so 2690 over 3. We don't multiply negative 1 by this because this is all supposed to be counted as one number, okay? And that's the reason why. They're not going to say, oh, negative 2690 over 3. I already multiplied it by negative by doing that right there. So if you're wondering, oh, do I multiply it in there? You don't. This is actually all one number, okay? And this right here would be our precise answer, okay? Then you can make it into a decimal and all that. All right. Going on now to the third problem. We have log base 5 of x plus log base 5 of x plus 4 equals 1. What we're going to have to do with this one is we have to use the product property, which says if you have one logarithm of two multiples, you can add them, right? Well, now we have to go backwards. So if I'm adding two logarithms, I can combine this whole thing into one logarithm. I can say that's the same thing as log base 5 as a product, right? That's why it's called the product property, as a product of x times x plus 4. So this whole thing all became this due to the product property. Because if you take this then and say, if you're going to expand it, you would get back that there. Okay? Equals 1. So that was the first part of this, is to use the product property. Now the next part, you had to have recognized that you can convert this logarithm into an exponential equation, right? Where we take the base is equal to what it's equal to of this. So this is the same thing as saying 5 to the 1, 5 to the power of 1, equals this whole thing. X squared plus 4x, and I just multiplied this out right now, all right? So I did x times x squared, x times 4 is 4x. And 5 to the power 1 is just 5 there, okay? So it looks like right here, going back now to your algebra skills, this is going to be a quadratic, right? And anytime that we have a quadratic, most of the time we want to put all the terms on one side and see if it's factorable. So I'm going to move this 5 over here. So we get 0 equals x squared plus 4x minus 5. Now we're going to do the good old diamond days, right? That's one way to factor this, where you do your little diamond. Okay, and we put the last number on top and put the middle number on the bottom. Two numbers that multiply and give us 5, and then when we add them we get 4. So it looks like that's going to be 5 and negative 1. 5 times negative 1 is negative 5. 5 plus negative 1 is 4, right? So this whole thing just became our product of x plus 5 times x minus 1. Oops, I'm just going to move this down here just real quick here. Okay. So this whole thing all became this. Yeah, there's a lot of properties going on in this problem here. And if I said a times b equals 0, what's your conclusion about either a or b? One has to be 0, right? So that's the reason why I'm going to set this equal to 0 and set this, because you can think of this as our a and then think of this as our b. Either this whole thing is 0 or this whole thing is 0. So we set x plus 5 equals 0 and x minus 1 equals 0. Because one of them is going to have to down to be 0 right there. So if we solve for x, x equals -5, and x equals 1. We're finally done! Yeah! Oh, maybe we're not quite done here. Because if you wrote this on your exam, and you did all this work, you're like, I'm feeling good. You actually did not get full credits. You got a point or two taken off. This is why, okay? If you were to plug this value of -5 and this value of 1 back into our original equation, okay? So if I plug in -5 right here, and if I plug in 1, okay? We've learned that, say if I plug in -5, log base 5 of -5. If you were to try to do this in your calculator, you would get an error message. It gets mad. It goes, error. Well, there's an error. It's not possible because, think about this. Write this in exponential form. 5 to the power of what equals -5? Let's think here. If I put in positive values, it's going to give me a positive value. And then even if I put in negative values here, okay, it's going to give me just fractions, right? Like if I do 5 to the -1, well, that's just 1 over 5 to the power of 1, right? So it's not possible to take a logarithm of a negative number. So basically what you have to say is this, is you cross this out, and you say that that's what we call an extraneous answer, okay? Did I spell that right? I hope so. It's called an extraneous, which means that it's a solution that we got, but then when you test it, it doesn't make it true. So this actually -5 is not a solution. This is the answer, and to get the full points, you would have to have done that, and that would really show that you really are a proficient student from skills from Algebra 1, skills from Algebra 2, skills, also more Algebra 2. I mean, this is a lot of stuff that you've had to have remembered. And I guess it's back on now for the next two parts of this problem here.